Okay, so I'm gonna start with some basics, um, just giving you an idea about how the fish got into Vermont in the first place, um, what their habitat needs are, what specific species habitat needs are, what some of the factors are. Um, get a little bit into interspecies interactions, but just kind of a glancing blow just to give you some background. So first, there are two ways that fish got into the state. The first thing we have to know is how do they get here in the first place? And as most of you might guess, um, following the passage of the last Wisconsin glacier, fish moved into the rather large meltwater lakes and rivers from refugia um, located pretty much to the south and west and a little bit to the east below the glacier. Um, so that's all the fish that arrived in the state between 8 and 14,000 years ago are designated as native species. Anybody else that got in after that is a non-native species, which brings us to number two, human activities. Primarily stocking game fish is responsible for most of our non-native occurrences. There are some other reasons too. Some lakes have been stocked with forage fish, other lakes and rivers, you get bait bucket releases, non-biologists thinking that, hey, you know, this species would be great in this lake, like alewives in Lake St. Catherine. Bad choice. Otherwise, there's a possibility that some of the species have moved in through canals, and primarily in the Champlain Valley, Richelieu River, the Chambly Canal up in the north, and the Champlain Canal to the south have undoubtedly introduced a few species, not many, but a few. Okay, why am I not going here? Okay, oh, I know what I am. I gotta play it here. Okay, that's why it's not, okay. Ah, there we go. I've got some animations here, all right. Okay, so we're starting with glaciation. This is a slide that I put together in another presentation depicting the southernmost advancement of the last glaciation. About 16,000 years ago in our area reached the area of Long Island. Fish and everybody else avoided the glacier by hanging out in refugia to the south, the Mississippian refugium being the largest in terms of fish species. These are designated in our state as western species. They did not get access naturally to the Connecticut drainage, which is important. Over to our right, the Atlantic drainage, the coastal plain fishes, eastern refugial fish species hung out here for a while. As the glacier moved northwards, they followed the meltwater rivers up the Hudson Valley, some of them into Champlain. And you notice, can you see this? Can you see the whole slide, or we have people over here?
I can see it. I can see the blue polygon.
Okay.
Where your cursor
that represents the Georges Bank and Grand Banks. The glaciers, there was so much ice tied up in the glaciers that it sucked the oceans down about 400 feet.
Wow.
So it exposed the Grand Banks and Georges Bank. And
wow.
So a lot of freshwater fishes hung out there for 60,000 years.
Wow.
The Mississippian drainage has far more species than the Atlantic. This is a cool picture from Steve Trombulak's book. He's retired also. Shows the maximum extent of water body. It's really cool. The Lake Hitchcock was formed in the valley of the Connecticut River around 14,000 years ago. And being a lake, it allowed fish species to move up fairly easily. But we have to remember that the land was depressed 800 to 1,000 feet at the time, slowly rebounding. But a lot of these fishes got up into these areas like the White River here and some of the cold water streams, which are now at elevation 2,000 feet. Then it was only 1,000 feet, and they easily moved up into these areas. And as the land rebounded, they got stranded and permanently colonized those zones. Over in the western part of the state, Lake Vermont, this is its maximum extent during the post-glaciation. Obviously a very large lake. When the isostatic rebound caused the earth to rise slowly, it eventually dried up and stranded these species way up, especially in the Missisquoi Valley, which probably is close to 650 feet elevation now. The western species could have easily accessed at least to there. And down south here, the Poultney, 440 feet seems to be the maximum extent. So cutting this really short, there were three migrations of freshwater fishes from the west. The first migration took place via the Mohawk River, which drained the Great Lakes for a period of about 1,000 years ago. I'll show a map on this in a second. Second migration came right after that from the north through the St. Lawrence. Champlain Sea interceded for about 1,500 years and gave us three native species, rainbow smelt, Atlantic salmon, and sea lamprey. Third migration, after the earth rebounded, it shut out the Champlain Sea very slowly. The valley freshened, and we had access availability to the Great Lakes via the St. Lawrence River for about 2,000 years. Eventually, the land rebounded, and physical barriers were set up on the Richelieu, which prevented any further migration of Western species. This is a kind of a cool slide that I like. Ignore the arrows.
yeah.
I don't know why they're there. Maximum extent of Lake Iroquois, much larger than the current Lake Ontario. As I said, the Great Lakes drained much in the way they do now, but they hit the glacier, which acted as a dam in the St. Lawrence Valley. The Mohawk River was, the area in the valley was still depressed fairly in relationship to what it is today. And it provided for about 1,000 years the outlet to the Great Lakes, and allowed freshwater species to move through there, turn left into the Coville phase of Lake Vermont, or turn right and go down into the Hudson. I wanted to just say briefly, eastern species got in also to western parts of the state, but the opposite did not occur. And that's another story. Okay, first two migrations, let me go back here. But before I leave this slide, Covey Hill, Quebec, right on the border here. The ice dam eventually gave way, and from geologic papers, I understand it gave way in a matter of hours, and over 3 million cubic feet of water flushed out of here catastrophically for a week. Wow. And it cleared out 12 acres. It took 12 acres of soil off the off of northern New York near Altona, and it's called the Altona Flats, and it's all bare. It's all bare rock.
Wow.
And this had the effect of injecting species into Lake Champlain or Lake Vermont at the time. I mean, it literally pushed them in there. So
wow.
Cool. I'd have loved to have been there
up in New York there.
Pardon me?
Now I'll have to visit that spot up in New York there.
Oh yeah, yeah. I've never been up there, but I'd love to see it.
Wow.
Okay. Champlain Sea, as I said, the Earth's crust is continually rebounding. It took it, a good 5,000 years to get where it is about now. The Champlain Sea eventually gave way to a freshwater lake in the St. Lawrence, which allowed the third and final migration of Western species into the state of Vermont. Vermont has more native species than any other New England state because of its connection to the Great Lakes.
Interesting.
Okay, just a little bit of background on, okay, once the fish get here, can they stay here? Water chemistry parameters, temperature and pH are very huge. They're very big in determining who's going to be where for how long. Temperature-wise, I like to look at temperature tolerances in 3 groups. The stenotherms, warm water stenotherms, cold water stenotherms. Steno meaning narrow range. Eurytherms, which represents a larger group of fish, at least in Vermont, occupies the entire state. And most of our fish species are eurythermal species. Cold water species, of course, brook trout, slimy sculpin, long-nosed sucker, and a few others. Warm water species, largemouth bass, bowfin, gar, things along those lines. Physical habitat, is the water flowing or standing? How high is the gradient? How high is the velocity? Are their bodies shaped to handle that sort of thing? Sunfish? No. Long-nosed dace, long-nosed suckers? Yes, very streamlined. Depth and volume of habitat. The more depth you have, the more habitat volume you have, generally the more fish species that particular habitat can support. Substrate, do they like rock, mud, sand, plants? Some fish are not found around plants. Try fishing for smallmouth bass in a swamp. You'll never get one. Largemouth, yes, not smallmouth. Mud and sand, good for bullhead, all the catfish families, rocks, smallmouth bass, sometimes perch, but they prefer plants, so forth and so on. Species interactions, predation. How big are the predators? How many are there? For a particular species, is there enough food for them? The prey type and availability, the timing of their availability, and of course competition for spawning sites, and most importantly for food. In Vermont, these factors above are all driven primarily by elevation and drainage area. 2 very important factors in determining not only the habitat type, but the assemblage type as well. This goes for macroinvertebrates as well as fish. 2 very big, high correlation factors here. Generally, the higher the elevation, the colder the water. Most of you know that. Generally, the higher the elevation, the smaller the drainage area, generally. Larger drainage areas are often found in middle to lower elevation drainages, lower elevations as well. All right, now we're getting down to the biology. I chaired a group, a really interesting group of folks that classified assemblage types back in the 1990s of aquatic habitat. My specialty was fish or running waters, and I came up with 6 basic assemblage types. There are 10 total in the state. The other 4 are very small and specialized over in the Connecticut Valley. These 6 assemblage types are found just about everywhere within the state. We determined assemblage types by similarity, by biological similarities. In other words, clusters of like species formed the assemblage types. Other attempts at classification have tried to guess what physical factors might be important and then sandwich and push in, shove and push assemblages in to fit that, which we thought was kind of back-asswards. So we went with the biological approach. We used 2-way two-way species analysis, twin span, and it's a visual and numeric type of analytical tool that helps us out quite a bit. And it was also something that us dumb biologists could actually understand, which was good. So anyway, as we go down from 1 to 6, the factors in the right tended to follow a gradient, a predictable gradient. The brook trout assemblage type, in those waters only brook trout occur. There's just one species. The water type is cold, elevation is generally high, drainage is small. Move downstream a little bit and you get brook trout and slimy sculpin, possibly black-nosed dace. Brook trout and slimy sculpin are cold water stenoforms. As you move down, as you advance the assemblage types, the total species increases. The water type goes from cold to warm. Elevation generally goes from high to low, and drainage size goes from small to large. As I said, Lewis Creek has all 6 of these, which makes it very interesting and very tempting to draw a map that I attempted to draw at the end of the presentation. Okay, finally we're getting down to it. This is loaded with information. I'm spend a little time here. Let me introduce the rows at the top. I didn't have time, I didn't have the space to list everything here. So the elevations are on the top row, starting at lake level, 100 feet. They represent our sampling sites. We have about 11 on the creek itself. For the middle types, I combined 2 sites because we only sampled them once. Second row is I attempted to give you guys an idea where the particular sites were. 640 feet, that was Ireland Road, was off a private residence. We had to go down a 9,000-foot slope to get into the place. It was beautiful, absolutely gorgeous.
I remember that. Yeah.
Yeah. And then we hit Parsonage Road for a few years, the Parsonage Road Bridge in Starksboro. I think that the wreck field is around 500 to 532 feet, I believe. But anyway, as you go from type 1, which is a brook trout only, to type 2, type 3, you start picking up species. What I did here is I placed Western species in red. So every red species there is from the Western refugia. The dark ones are either from the east or from both. They came from both the west and the east, which makes it kind of confusing.
That's cool.
And minnows are in italics. And I did that to emphasize the fact that in all of our fish sampling, minnows have dominated just about every type, from probably type 3 all the way on down to type 6. We have about 27 native minnow species within the state. And if I don't ever see a black-nosed dace again, I'm not going to be unhappy. I once calculated how many black-nosed dace had passed through my fingers counting over the bucket, and it was close to 100,000.
Oh,
ridiculous. We did have our most the highest density site I think we ever had in any sizable stream was at the Quinlan Bridge when Brian Shipman was sampling with me back in the 90s. It took us, we sampled a very short section, maybe 50 meters. We got over 4,000 fish in 50 meters of water. And
what does that mean?
Well, it means that there was some nutrients going in there,
Productive.
It was supercharged. It didn't look gross or anything, as I recall. There wasn't excessive algal growth, but there was an unbelievable amount of productivity there. And that seemed to be the only site. So it took us about 2.5 hours sitting there over our bucket stream. Anyway, as you see, going from type 1 down to type 6, these species generally increase. Type 3, you get more minnows. You start to see western species, red-bellied dace. And as you go down into type 4, I wasn't sure about this area here, type 4 or 5, it seemed like a transition. You're really getting into some, not only western species or minnow species, you're getting into some eurythermal species. Most of these species here are eurythermal. You notice by type 4, you still have brook trout and slimy sculpin, but they are extremely rare. By type 5, they drop out. And they're replaced by some warm water stenotherms, especially in type 5. Lots of western species there. You're getting pumpkin seeds, smallmouth bass, northern pike. I've gotten a few pike at our Route 7 site. Last time I sampled there, we've got about 8 American eels, which was just a blast. They are so much fun to electrofish because you don't see them, they're all hidden. And all of a sudden these big things come blasting out of the water. And I was doing it I was teaching a class, one of Steve Trombulak's classes from Middlebury, a natural history class, and there was like 15 kids in the water. We had 3 electroshockers, and they were having a blast. It was great. But anyway, it's nice to see the eels back.
Wow.
Well, that's type 3, average about, well, we have 23 species here in Lewis Creek. And finally, we get down to Greenbush Road, which is lake level, easy access from the lake. Every fish species that can exist in a riverine environment is there. Silver lamprey, mimic shiner, log perch, largemouth bass, of course, chain pickerel, pike, you name it, bowfin. A lot of warm water species there, a lot of western species, and of course a lot of minnows. So I should have stopped and asked if anybody had any questions. I've been blasting along here.
How many species overall are in the system?
That's a good question. It'd have
Roughly.
Yeah, I would say everything in type 5 and 6, and yeah, I can answer that later. Yeah, it would be
Okay.
27 plus all, slimy sculpin, brook trout, a few others. I would say probably 35 around, which is pretty good. Which is pretty good.
Yeah, okay.
As I said, Lewis Creek is unique in terms of that it has all 6 classifications, all 6 assemblage types, in a fairly short distance of stream. We're talking about what, 33 miles?
Yeah.
It's the only other rivers that do that are the Poultney, Otter, Winooski, Lamoille, and Missisquoi, pretty much. And they're all 2 to 3 times, the size. So we have a good little microcosm of the assemblages here, which is fairly well defined. Notice that I didn't address the falls here. The Ferrisburg Falls represents a physical barrier to upstream migration of all species except sea lamprey, and if they are wherever there are Atlantic salmon, could have probably gotten up there. It's much like the fall lines do on some of the major rivers. They're a little more dramatic, and they do represent barriers to sea lamprey because they're so high. So,
is type 4 the Prison Hollow Falls?
Prison Hollow would be, yes, I would say it's somewhere along in there. Yep. Now,
That's that elevation change.
Yeah, the 300, 325, I think, somewhere along in here.
Yeah. Okay.
I put down rec field. It was like maybe 35 years ago when I sampled that. And I remember a rec field going down. It was a slow area. I remember getting brown bullhead there and being kind of surprised. But yeah, it's a typical type 3 down there. Yeah, it's, so another way to depict this is using a map, and these are pretty much the zones that I've established. These are really wide lines, gray lines. They're a little bit arbitrary. but they give you the idea of succession from one to 6. The type 4 area is pretty large. That could vary the more we sample. 20 years from now, we might be able to hone that down. Brad, a little more time. I got a couple more slides.
How are we doing for time, Kate?
Yeah, we're a little over, but I think we might as well see a couple more slides, right?
Okay.
Yeah, and then we can have questions.
Yes.
Okay. This is a slide I show on my distribution talk. Just shows a timeline of fish invasions into Lake Champlain via the canals. Blueback herring in 79, white perch in 84, gizzard shad and white crappie in 1993, brook silverside in 98. We're not sure if that's an invasive or not. It's a very small, short-lived fish. It's almost transparent. Interesting thing is that in 1998, I found it up in Grand Isle in North Hero. Ellen Marsden from UVM found it in Keeler Bay, and a bait dealer found it in the Poultney River, all within 2 months of each other. On that
Wow.
and so Chet McKenzie and Ellen and I got a paper out of it. Anyway, Tench came. Tench came in, and well, I can't quite see it. I think it's '08. Illegal farm up in Quebec. I guess they had a blowout of their outlet pipes, got into the river, and it was only a matter of time. They're spreading it throughout the lake. They're a rough game fish over in Europe, and they can probably be eaten here as well. And I think my last one, to give you an idea of native, non-native, the state of Vermont is about 77 native species. We're not sure on a couple. 17 non-natives, a total of 94 species for the entire state. Champlain drainage alone has 74 of those native species and 15 of the non-native species, which I've just given you a few of. One more thing I needed to say with the types here, you noticed those of you who angle for brown and brook trout, I didn't include stocked non-native fish in this because this was a natural assemblage classification. We find browns typically, occasionally and rarely in type 5, but more often in type 4, type 3, browns along with some rainbows along with the brook trout. So that's it. I got to quit.